Hey everyone, and welcome. Today, we are cracking a code, and this code is written into the world all around us. I'm talking about quadratic equations. Now, don't let that name scare you off. Seriously, think of them less like some scary math problem and more like a blueprint for describing, well, everything from the curve of a satellite dish to the perfect arc of a basketball shot.
So, to see what I mean, let's start with a really simple question. You're outside, you throw a ball straight up into the air. How can you know exactly when it will hit the ground? It seems pretty complicated, right? But the answer is just waiting for us inside a specific kind of code.
And here it is. This is the code. This is the quadratic equation for projectile motion. Now, it might look a little intense at first, but h of t is really just the height of the ball at any given time t. So, to find out when it lands, all we have to do is find the time t when the height h of t is 0. In other words, when the ball is back on the ground. And that is exactly what we're here to do. Learn how to solve this kind of code.
Okay, so here's our game plan. First, we're going to understand the puzzle itself, this thing called the parabola. Then, we'll build a toolkit with 3 really powerful methods to solve it. The kind of elegant art of factoring, the unstoppable power of the quadratic formula, and the sheer clarity of a visual, graphical solution. And then, at the end, we'll learn how to choose the right tool for any job.
So, every single quadratic equation tells the story of a shape called a parabola. Let's get to know its fundamental blueprint, what makes it tick. At the very heart of every parabola is this standard form, ax squared plus bx plus c equals 0. The key players here are a, b, and c. These are the coefficients that define the specific shape of our curve. A is always attached to the x squared term, b is with the x term, and c is just that constant, standing on its own. You really want to get to know these 3, because they are the keys to unlocking everything.
And you know what's wild? Just look how much that one single value, a, tells us. If a is positive, the parabola opens upwards, kind of like a smile. If a is negative, it opens downwards, like a frown. Or, the path of that ball we just threw. It's really that simple.
Okay, let's grab our first tool. I want you to think of factoring as the craftsman's method. It's elegant, it's precise, and honestly, when it works, it's incredibly satisfying. The AC method is a perfect example of this. Let's just walk through it together. First up, you multiply a and c. So for our equation, that's 2 times 5, which gives us 10. Simple enough. Next, we need to find 2 numbers that multiply to that 10, but, and this is key, add up to our b value, which is negative 11. After a little thought, we find them, negative 10 and negative 1. Now for the really clever part. We use those 2 numbers to split our middle term. Then we group these new terms together and just pull out the common factors. This neat little process leaves us with our final factored form, 2x minus 1 and x minus 5. Boom.
Of course, the AC method isn't the only way to do it. As this Reddit user points out, a lot of us just learn by guess and check in school. And it kind of speaks to a shared experience, right? Sometimes you just develop an intuition for it. But when that intuition fails, we need something a little more reliable.
And that brings us to the power tool in our toolkit, the one method that will never, ever let you down, no matter how messy or complicated the equation gets. I'm talking about the unfailing quadratic formula.
And there it is, in all its glory. You just plug in your a, b, and c values, and this formula will literally spit out the answer every single time. It is the universal key. It unlocks any quadratic equation you will ever face. I absolutely love this quote from that same Reddit thread because it just perfectly captures the feeling. Factoring is great for, pretty problems. But as one user notes, in the real world, the numbers are rarely perfect. The formula might look a little icky, as they put it, but it is the undisputed champion for its raw power and its reliability. Now, hidden inside that big formula is this awesome little secret feature called the discriminant. It's that b squared minus 4ac part that's stuck under the square root. I want you to think of it like a preview button. Before you even solve the whole thing, the discriminant tells you exactly what kind of answer you're about to get. So here's how it works. If the discriminant is positive, you're going to have 2 different real solutions. If it's 0, you'll have exactly 1 solution. And if it's negative, well, since you can't take the square root of a negative number in the real number system, it just means there are no real solutions. That parabola never even crosses the x-axis.
All right, our final tool is maybe the most intuitive one, and it's kind of a beautiful one too, because sometimes the best way to solve an equation is to simply look at a picture of it. This really gets to the core of it.
When we set a quadratic equation to 0, what we're really asking is a visual question. Where does this parabola cross the horizontal x-axis? The answers, which we call the solutions or the roots, are simply the x-intercepts you can literally see on the graph.
Now, to sketch that graph accurately, the most important point you need to find is the vertex. That's the lowest or the highest point of the parabola. And guess what? There's a handy little formula for that too. The x-coordinate of the vertex is always -b divided by 2a. For our thrown ball, this would give us the exact time it reaches its highest point. Then you just plug that x value back into the original equation, and you'll find the y-coordinate. It's the perfect starting point for your sketch.
So now we have our full toolkit: the craftsman's factoring, the powerful formula, and the visual graph. The big question is, how do we know which one to pick for the job?
This right here sums it all up. This is your game plan. If the equation looks simple and the numbers are small, hey, give factoring a shot first. It's fast and it's clean. If it looks messy or if you get stuck factoring, don't waste time. Just go straight for the formula. It always works. And if you really need to understand the big picture, like the maximum height of that ball we threw, graphing is going to be your best friend.
So there you have it, the code behind the curve. It's a language that describes the flight of a ball, the shape of a bridge, even economic models for profit. You now have a complete toolkit to read and to solve that code. The only question left is, what problems will you solve?